We're going to begin today looking at several different skills that are going to lead us to being able to solve quadratics by factoring. So as I mentioned when we were talking about greatest common factors, that it's really important that we understand what a factor is. So in the statement 2 times 3 equals 6, 2 and 3 are the factors, the things that are being multiplied. Those are the factors. When we factor, we're taking a sum and rewriting it to be able to express it as a product. So for example, if I look at this first thing that I've got here, x squared plus 4x minus 12, that's a sum. I'm adding three different terms together. But then when I take it over here and change it to multiplication, now I've got two factors and I'm representing that same expression as a product of x plus 6 and x minus 2. So that's our goal, is to be able to get things factored. So if you remember what we worked with on Thursday, we looked at how we can use the distributive property to multiply two binomials. So what we did, and I'm writing this kind of funny and I'm doing it on purpose, was we took each of these terms and we distributed it. So the first thing I did was I took the x and I distributed that to 2x minus 3. So we got 2x squared minus 3x. And then we took the plus 4 and we distributed that to 2x minus 3. So here and here. So now I have plus 8x minus 12. And then we had these two like terms, so we go ahead and combine those. And so the final product was 2x squared plus 5x minus 12. And I apologize, I'm using a stylus that I have at home and it's not very good. So those are sort of the steps that we're going to follow through. We took the first term, we split it apart, we distributed it to the same factor twice, and then we combined our like terms. Well, when we look at factoring, we're going to do this process of factoring by grouping, which does this exact process in reverse. So there are 4 steps to factor this expression. And you'll notice this was the exact same expression that we just got as our answer before. So I kind of set it up that way on purpose. So the first thing that we're going to do, and it's important to note, this is always when looking at a quadratic in standard form. So it's got to be ax squared plus bx plus c. And that's important because the values of a, b, and c are going to play a big part in how we set this up by grouping. So the first thing we're going to do is set up a diamond problem. Now this is kind of a weird thing that I do to set this up. I'm a very visual person, so this is helpful to me. So this is my X diamond, whatever. I've always called them diamonds, but I realize it's just an X. So what we're going to do is we're going to take A times C, and that's going to go in the top of our diamond. So again, that's going to be the A and the C from right here. And then whatever B is going to go on the top. And what we're trying to figure out is we want two numbers that multiply to give me the same number that's on the top. And we want those same two numbers to add to give me the numbers that are on the bottom. Here's an example. Okay, let's say that I had 8 and 6. So I want to think of two numbers so that when I multiply them, I get 8, and when I add them, I get 6. Well, 2 and 4 would do the trick because, again, what we're trying to do, 2 times 4 equals 8, and 2 plus 4 equals 6. Now, it gets a little tricky when we look at things like negatives because you got to remember a negative times a negative can make a positive times a positive can make a positive, and different ways that we can add and subtract our negatives. So let's see how I would set that up for this particular example. Again, over here in green, what I am going to set up is I'm going to take, this is A, this is B, and this is C. So when I set this up, A times C, and notice that C is negative 12, so I'm going to get negative 24. And then B on the bottom is 5. Now go ahead and put me on pause and try to figure out what those side numbers would be. When I can't figure it out, I always make a list of factors before I try to say this is not factorable or whatever. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now I want to look, and the fact that this is negative means that I can add or subtract. And I see that 3 and 8 is going to add or subtract to give me 5. So I'm going to use 3 and I'm going to use 8. And then I look at the 5 and I say, well, that's positive, so I need more positives than negatives, and that's how I decide that my 3 is going to be negative. So I've solved now the diamond problem that goes along with the expression we're trying to factor. Now, step 2 is we're going to use the side numbers. So when I say the side numbers, we're talking about the solutions to our diamond, to uncombine the bx term from the problem. Now, if you look at the example that we did before where we multiplied, remember our last step was to combine those two middle terms. Well, what we want to do now is we want to uncombine them. So I'm going to take the 5x and I'm going to take that out. The 2x squared is going to stay exactly the same. The minus 12 is going to stay exactly the same. But now these two, I'm going to stick back in, minus 3x plus 8x. And now, I always remind myself right here, x is out, x is in. Meaning, since I'm taking out a middle term that has an x on it, you have to make sure you remember to put these x's back on when you substitute in. Otherwise, it's not going to work the way that we want it to. Okay, so step 3, now that I have 4 terms, I have an equal number of terms. And so what I'm going to do is chop up the expression after the second term. I'm going to cut it in half. This is why it's called factoring by grouping, because I now just made 2 groups, this one and this one. And so what we're going to do is we're going to take out the GCF from each half. This is why this is so important that we did on Thursday. So if I look at 2 and 3, looking at the first group, nothing comes out of both 2 and 3. Then I look at x squared and x, and I can take an x out of both of those. So x is my GCF. If I divide each of those by x, I get 2x and then minus 3. Now, super important, you always have to have a sign here, and it's always going to match whatever the sign was above. That's important because when we get to ones that have negatives, that's going to cause a problem if we don't catch that. So now I look at 8 and 12, and I can divide both of those by 4. And they don't both have an x, so I can't take any x's out of this one. But when I divide them both by 4, I get 2x minus 3. Now check out what just happened here. 2x minus 3 and 2x minus 3. I ended up with the same factor in both cases. That's important. And if you look at what we just got here and look at that very first step we did in the multiplying, this is exactly what we did. So we have figured out what are the two things that we distributed to 2x minus 3. And so now, since they both have 2x minus 3 in common, now we're on to step 4. That's my dog. 2x minus 3 we can factor out. And if I take that away, then all I'm left with are these two things, x plus 4. And now we've gotten ourselves back to the multiplication problem, which is exactly what we wanted. So let's walk back through this just kind of step by step by step. So step 1 was to set up the diamond problem. We multiplied a times c, that's how we got negative 24 on the top, and then b just comes straight to the bottom. We picked negative 3 and 8 because they multiply to make negative 24 and they add to make 5. The second step was we took those two numbers, negative 3 and 8, x is out, x is in. And so we split that term into 2 terms so that we could divide it into 2 groups. The third step was to find the greatest common factor from each of the groups and factor that out. And then the final step was to pull out the factor that they each had in common, which was the 2x minus 3 right here, and the leftover parts make our second factor. So now I'm going to work through a couple of examples so that we can see what we get. Okay. We want to factor each expression. So, first thing we're going to do is set up our diamond. A is 4, C is 3, so we get 12, and then 13 is on the bottom. This one's a little bit tricky, but anytime I notice that I have a number that's just one bigger than what I have, I know it has to be 1 and 12. Okay? So now I'm going to take out my plus 13x, and I'm going to have 4x squared plus 1x plus 12x. They're both pluses because they're positive, and then plus 3. So now I'm ready to split this in half. The GCF of the first two is just going to be 1x, and when I divide that out, I get 4x plus 1. Plus, remember to bring this sign straight down. Now 3 is the GCF of these two, and I get 4x plus 1. I know I'm on the right track because these factors ended up being the same. So that means our factored form is 4x plus 1 and x plus 3. Number 8. Go ahead, I want you to put the video on pause and set up the diamond and see if you can figure out the numbers on the side. Here's what I get, and this is where it gets a little bit tricky. In order to multiply to a positive but add to a negative, I need these both to be negative numbers. A negative times a negative will give me positive 6, but when I add two negatives together, then I just get my negative 7. So now I'm going to take the negative 7x out, 3x squared, x is out, x is in, and now I can split this in half. This is a good example because here's one that has a minus. So the first group here, all I can take out is an x. So I get 3x minus 1. But remember I told you this sign has to stay exactly the same. So that means that I have to take out a negative this time. And the only thing they have in common is 2. But notice now that our GCF is negative 2. So when I divide, I have to say negative 6 divided by negative 2. That gives me positive 3x. And then positive 2 divided by negative 2 gives me negative 1. If I don't pay attention to those signs, I'm not going to get a common factor. So my common factor is 3x minus 1 and x minus 2. All right. Go ahead and try 9 and 10 so you can see if you're on the right track. I'll meet you back here with the answers. And here are the answers to both of these. Now there's a couple things that I want to point out here. Notice on number 9, when I split this apart, the only GCF that they had in common is 1. And usually we don't care about 1 as a greatest common factor. But because I have to have this piece for my factor over here, it's really important that you take out that plus 1 if there is nothing that comes out of the second group. So that's something that you want to remind yourself. And then on the last one, again, just make sure that you pay attention to this negative and remembering to switch the signs here when you divide. So there they are. I'm going to go ahead and do these last two examples so that you can get them copied down in your notes if you're not sure. If you want to go ahead and try these, go ahead and do that. But here are the answers. One thing that is important to note on number 11 is that it's the b term that is missing, so b is equal to 0. 4 and negative 25, that's a and c, so that's why we get negative 100 there on the top. That's kind of an important thing. And then notice here, a is not 0, a is 1 in that term that we have there. One last thing that I should point out is that the order of the factors doesn't matter, nor do the sides of your diamond. For example, on number 12, I put negative 4 on the left and negative 5 on the right, but if you did it backwards, you would still get the same answer. You might end up with your factors in the reverse order, but since 5 times 2 and 2 times 5 are both 10, the order doesn't matter when you multiply. All right, that's where we're going to stop today, and we'll practice this some more tomorrow.